Find the vertical asymptotes and hulls, if any, of the following functions. Well, we're going to do them both together. f of x is x minus 5 over 2x squared plus 7x plus 6. Step 1, see where the denominator equals 0. How does 2x squared plus 7x plus 6 factor? 2x plus 3, x plus 2. If you set each factor to 0, what do you get for x? Negative 3 halves and negative 2. Step 1, see where the denominator is 0. Is that okay? All right. Step 2, one at a time, put these numbers into the numerator. So if I put negative 3 halves into the numerator, which just says take whatever you get and subtract 5, does this equal 0? No. So since we did not get 0, what do we have at x equals negative 3 halves? Vertical asymptote. Now, make sure when you are answering, you don't say asymptote, because we're going to learn there's 3 different types of asymptotes. How about negative 2? If we plug in negative 2 into the numerator, do we get 0? No. So what happens at negative 2? Vertical asymptote. Whee! So that's the steps. Find where the denominator is 0, plug those numbers into the numerator. If you get 0, it's a whole. If you do not get 0, it's a vertical asymptote. Bink. X cubed minus 9x. How does that factor? Very good. It factors as x times x plus 3, x minus 3. Setting this equal to 0 and solving for x, what do you get? 0, negative 3, positive 3. Put these into the numerator. If you put in 0 into the numerator, do you get 0? No. So what happens at x equals 0? Vertical asymptote. If you put in 3, do you get 0? No. Think about it. You're squaring stuff. You're adding it to positive stuff. You're adding it to more positive stuff. That can't be 0. So x equals 3 is also a vertical asymptote. Oh, I don't know why I'm rewriting that. But what happens when you plug in negative 3? It equals 0. Please be careful with your negatives. Yep. So that means we have a hole at x equals negative 3. A hole is a missing point, meaning that if you were to graph it, you would just take that point out, and there would be your hole. Since a hole is a point, you need to provide an x and a y coordinate. We know the x coordinate is negative 3. We have to provide the y coordinate. To find the y coordinate, we need to erase some stuff because I don't have any room here. You know what? I can make another slide. I'll make another slide. All right, so we found that negative 3 is a hole. To figure out where the y coordinate is, you factor the numerator and the denominator. Well, the denominator we factored in step 1. How does the numerator factor? So let's look at this. If you're looking at the factorization, you can identify where your vertical asymptotes or holes are at based on where the factors are. If your factor only appears in the denominator, it's a vertical asymptote. Because notice, this gave us 0, and this gave us positive 3. And those are where the only times those factors appear. They only appear in the denominator. If your factor appears in the numerator and the denominator, that leads to a hole. So instead of doing these steps here, if you want to just factor it and show me the factorization and say, hey, this means hole, this means vertical asymptote, totally fine. Because that means you know how that works from by reverse engineering it. So factor the numerator and denominator. Check. Cancel your common factor. Double check. So g of x is now written as x plus 5 over, I picked the wrong color, x times x minus 3. Here's the deal. The g of x we have up top is not the same g of x as we have in the bottom line. The first one has a hole. The second one doesn't have a hole. If you're to graph them, they're going to look exactly the same because your calculator does not graph holes. So what you would have to say to the viewer to make them equal again is off to the side you would say x does not equal negative 3. And now that makes them the same equation. So once it's factored and reduced, to figure out the y-coordinate of the hole, you would plug in the x-coordinate into the reduced format, and this would tell you where the graph would have been if you did not have a hole. What do you get in the numerator? 2. What do you get in the denominator? 18. 2 18ths reduces down to 1/9. So your hole is at negative 3, 1/9, which means this is where the point would have been if the graph did not have a hole. But it's got a hole, so we took that point out. On the test, you do not have to explain to me how to find the y-coordinate of the hole. You can if you want to. You could leave your friends behind.